B reads x is less than or equal to 5. And guys, if you need a reminder on the names of these, that was on... I also gave away my 611, didn't I? I'm going to have to use one of your 611s. John, do you care if I show your 611? Cool, thanks. On your 611, because I have not gotten a chance to grade these yet, I have all your mastery stuff I need to give back today. But if you need a reminder of these names, we highlighted, thank you for highlighting, John, the line under it gives us or equal to. Whichever one it is, less than or greater than, that's or equal to. So over here, I'm going to mark my 5. I'm going to circle the 5. I'm going to shade less than. But then we also fill in our circle because the or equal to. And if you need to make yourself a reminder of that says or equal to, and that is why we shade in the circle, make that reminder for yourself. When it's or equal to, we fill it in. C is yours to do on your own. We had some issues on a homework from last week about this. A number is not pick a number, it's use a variable. So how they use n here, we often use x. If you want to use the first letter of your first name, like M for me, right? 7 more than a number. That is, like, guys, we gave you these questions back to back because this is not an inequality. This means addition, right? This means I'm going to take a number and add 7 to it. So if I choose M, just because Micah, or you can use X, because that's like the famous variable. So a number means a variable. Let's check the back, or actually I'll just go back to the answer key for a second. So they used N, right, as their first number. Then they used X for the second unknown number that they didn't have. On 31, Lucas?
That's what I was about to. Can we go over
Yeah, we might as well look at it. Thank you for asking. On 31, when they ask us to name... I'm going to color code this whole thing, guys. I got enough highlighters. A constant is what sort of number? A number we know. So, like, plus 7. That's a good constant. Or, like, the 1 inside of here. That could also be a constant. In part B, this is where people got confused. Because I talked with a couple people about this last week. The two factors are the two things being multiplied. So it's 2 is one of the factors, and the other factor is 4x plus 1. Because it's the things being multiplied. But for the two factors of 4 times x, what are the two things being multiplied there? Eve, you with me? Because you're not. Your eyes are shut, and you're like poking out your eye with a pencil. 4 times x is 4 times x. Those are our two factors. Literally, 4 is one of them. X is the other one. C, write an expression with a variable m coefficient. This might be something we're forgetting. Coefficient, and this was from 612. So you probably need your notes. Was it 1-2 or 1-3? No, it's from the front of this, isn't it? Yeah, you should have these vocabs on the front. I gave mine away. Coefficient is the number we're multiplying with. So they want us to use a coefficient of -3, though. So I'm going to rewrite, make a different one. So coefficient of -3, variable of m, and a constant of 17. Questions on how we end up with negative 3m. Negative 3 is the multiplier, what we call the coefficient of m. 17's our constant. It's a number we know. So in D, you could highlight in D, coefficient. What's our coefficient over here? Well, either the 4 or the 11, right? Both of those multiplied by variables are constant. I might as well use the same color we used up top. Our constant number that we know, negative 37. Term, there are 3 terms. 4x squared is a term. 11y is a term. Negative 37 is a term. The variables, we can talk about x squared and y being variables. So as long as you could do this on a test, that's what I care about. Like, I'm not looking for a big, long written explanation here. I just want to make sure you know what constants and coefficients are. Yeah. So E is trying to remember or like remind us what's the difference between like a product and a quotient. So if we talk about a quotient, what's a quotient talk about? Lucas?
If I'm correct, it's yes, it's what you just squared in.
Yeah, it's division.
Yeah.
Quotient is the fancy word for division. Quotient is the fancy word for division. Product, fancy word for multiplication. This is multiplication. 8 times m plus n. And guys, if you struggled on this problem, what are the first 5 words I say in the problem? Read the math notes box, which is the vocab I've given you back here. Like, and there's all, I'm gonna flip back, but guys, I put this on your worksheet so it's quick and accessible. But if you're actually looking for the math notes box, if we went to the 613 lesson, like it says, read the math notes box in this lesson, and we go, ooh, look, algebra vocabulary. Here's all of our information about algebra vocabulary in our textbook for us. You should have your physical textbook still, and of course you've got the ebook. Sum, this is tricky because people fall into the trap of sum has to be addition. Sum is either addition or subtraction, so you can do sum as well, but if I really want it to be addition, there's a sum right here. M plus n, there's a sum right there. And then factor, well, I just highlighted a factor. The other factor there would be 8 or negative 8. So the biggest thing is if I give you a quiz on Friday, cough, cough, nudge, nudge. If I give you a quiz on Friday about vocab, do these words make sense to us? I don't need big, long written story here. If you highlight, if you know the pieces, totally fine. Now let's go back to the key for a second. So 32, 33, 34. 34A might have been a bit tricky, and sorry about the hole punch on 34B. Ignore that hole punch. It is still there. We're going to imagine it's still there. If you don't have this done and you have no idea how to do it, you should be asking. Ooh, and Kylie. Sorry, Kylie, what's up?
I've been confused for a lot, the area and the perimeter with the X tiles.
Yeah, thank you for asking. So area is how much space they take up. I'll be like honest here. Area is easier. Perimeter's the tough part here. So area, I have 4 X's and 4 1 tiles, our area is essentially naming the group that we have. So my area here is 4x plus 4. My area over here, 2x plus 5. But perimeter gets made tough when we have sections like here, and I'm meaning that section, or sections like over here, because they're not entire x's. This, if I am labeling all the way around my shape, is x, but then I'm missing how much of it? 3, because this length on bottom, this is all of x, right? That's an entire x. This up here would be x, except for the fact that they took away these 3 by stacking these blocks on there. So that is x minus 3 in that little section right there. The end, the short end of the x tile is 1, which reminds me this is on the floor, so I want to pick it up. I think it means it broke. Yep. So remember we talked about x? We don't know how long it is, if I can put my x back together. But the ends are always 1, right? X changes length, but the ends are always 1, like I have labeled right there on this x tile. Ends are always 1. So then I'm not going to do the rest of this one for you because I need to be able to see if you can label it correctly. If you can't, come work with me. But over here, this would be x, except for it's missing how much? 1. Sorry, that's x minus 1. And over here would be x minus 1. So remember, guys, that is not negative x. It's still positive x. It's negative 1. Or minus 1 from all the ones that you get. So when I go to check your homework, I should see labeling around this whole thing. Right? Not just those pieces I just labeled, but the whole thing should have labels on it. And then we add it all up. A reminder in 32, anytime we're looking for a percentage, we can do that part divided by whole. And then times 100. That we practiced on the mastery that I'm about to give back to some of you. So if this is done, 613, turn it in. If you still have your Chapter 5 Mastery follow-up, turn that in. I do not have any of the homework, so it's all just the Mastery follow-up. I will give you homework back tomorrow, because I still got to get those in. I will give you homework back tomorrow.
Oh, there you are. I was looking for it. I think that's on yours.
I do have homework back here. You turned in a bunch. Thank you very much, Tyler. Getting all caught up. Awesome work. You weren't here to get this back last week.
You're welcome.
And same with these. Great work. All right, all those answers are recorded. I was also chatting with a parent over the weekend about answers. Guys, I will send that PDF of answers to your parent if they're like trying to help you with math and they want some confirmation. I just don't really send it out to kids, right? It's too tempting to just be able to see the answers and just write down the answers. It's too tempting. You can use the homework help website, and a lot of those questions take you to the answer. But you should read the stuff in between. Getting to just the answers, it's a little too powerful. All right, real quick before we move on. When we talk about the boundary point, as we move on and keep solving these problems, the boundary point is the cutoff. It is where we start or stop. It is sometimes shaded. It sometimes isn't. So this example from our book would be like if we said, hey, graph on a number line, x is equal to 12. Okay, 12, right there. But if somebody tells you graph x is greater than or equal to 12, we put our boundary point on the, and you don't have to write any of this down. I'm just reviewing this because it's what we did last week, and we're in a new week. We had a 3-day weekend, but I should have eyes up here. X is 12, shades in that point. But then x is greater than, we shade to the right, and we put an arrow on our shading. Because it could be, like we said last week, like 8 billion. Right? Any number bigger than 12. So remember, this stuff is all always in your textbook if you need help. This would be x is less than 7. Why is my boundary point not shaded? Antonella? It's not or equal. We have to have the or equal to shade in the boundary point. Questions? All right, let's dive into new stuff. We only got like 20 minutes. All right, so today we are looking at solving equations, and I think we're going bowling. Sorry, we already went bowling, so you can't even be mad at me. Like, we took you guys bowling. Lucas?
What is kind of the, what can you put at the top?
Solving equations.
Okay.
Yep, sorry, I can put it down here too, right next to where we're actually going to start working. Solving. Guys, I'm going to be honest with you. The E word might start to come out a tiny bit. This is easier than what we did last week. Because now, instead of a question mark in the middle, like we're comparing left side, right side, and we're like, crap, we don't know what x is. Now, we can figure out x. So, Sandeep works at a bowling alley that currently charges $3 to rent shoes and $4 per game. His boss is thinking about changing things up, and they're going to charge $11 to rent shoes and $2 per game. I got to double check that this isn't on our work, because I think I put a couple things on your worksheet.
It's on our worksheet.
Yeah, this is on your sheet, so this should still be out. Guys, like we said, if it says examples from class, do not put this away. If I was you, I'd have 2 different colors of highlighter. Doesn't matter what colors. But if I was highlighting the important part on this problem, currently charges $3 to rent shoes, $4 per game. Versus $11 to rent shoes, $2 per game. How many pairs of shoes do you need when you go bowling? Yeah, so we only have to pay that once. How many games are you going to play? We don't know yet. Right? So if we go to write this out, over here, guys, I would not write this in A yet. Over here, we're going to say, well, this is like 3 plus 4 times, do we know how many games? No. So 4 times like a variable, right? Something we don't know. Try to do that for what I have highlighted in green up here, for what his boss is thinking about charging. I'm going to come back up here because it's a bit nicer when I write on the board. I know it's a bit bigger. So in orange. Anyone who would have helped me with what his boss is thinking, what expression we could use for that? Layla? 11 for the shoes plus 2 times however many games we play. If a customer plays 2 games, This is part A on your paper. If a customer plays 2 games, which model is cheaper? Chat with your group. Take a minute or two. We now are going to know how many games. We're going to know how many games. So you could do that work on your paper. I'm probably actually going to write it. I'll write it up here, but I should see work on your paper. This is part A. I'm skipping B right now.
Jamie, do you copy?
Whoa, my radio is loud. No one's been on the radio yet this morning. So now we know what X is. Ooh, if you want to make a note, if this is a little confusing for you, you could make a note up here that is like X games. We're going to play X games. It's our unknown. With the original, what I have in orange, what do we do first there? Isabella, what do we do first with 3 plus 4 times 2? Do we do the addition or the multiplication? Yeah, we multiply first. So that's going to be 3 plus 8. What's 3 plus 8? 11. Guys, I'm going to start to be a pain about labels. Because I asked a few of you on your follow-up, like, oh, what label should this have? And then you couldn't remember. Because you didn't write down any. So some of you need to come see me to talk about labels. Over here, exactly like what Isabella already told us, we multiply before we add. So with 2 games, which one is cheaper? The original. But now for part B, do it again, but for 7 games. So we're doing the same thing, but now X will be 7. We're doing the same thing, but now X will be 7. I'm going to erase the old work. You don't have to erase because you've got space on your paper. Ooh, 7 games got expensive over there. What's the original model add up to now? $31. We should have a label. Versus 11 plus 14? $25. So now the new model. Oh, this reach is not working. Now the new model is the cheaper way. Oh, good. I did plan this out correctly. I just don't know if I put it on my smartboard thing right. So, Sandeep decides to use his resources to figure this out. his boss wants to know when will the old model and the new model be equal. So he sets up this map, which is on your paper. This is on your paper. It's on your paper. Do what we did last week to simplify both sides of just this mat. Ignore the other two. There are two other ones. Just this mat. Ignore the other ones. Apparently this doesn't want to work with me. I will get it another one. Anybody, can we make zeros? No. Sorry, my technology decided not to agree with me. So if I can't make zeros, Farah, can you tell me something I can do?
You can remove 4x from mat A. Well, no, wait, 2x.
Ooh, I can remove 2 x's from both mats, right? So Farah says I can take these out of here as long as I take this off and this off. So the first thing we did was minus 2x to both sides. I think we've got a little space down here. If you want to write what we're doing, you could write minus 2x from both sides. So then, Franco, what else could we do? Ooh, take away 3 of the 1s, as long as we take away these 3. So I have minus 3 from both sides. Vincent, what do I see now? Like, what's on my left side? Wait, what's on my left side?
2x.
Yeah, I got 2x now. So we now have 2x. And what do I have on my right side? 8. And what if I tell you these are equal? What would x have to be? Anybody? 4. So if we play 4 games, the prices would be equal. Because that mat showed us the bowling alley problem. That was the bowling alley problem. I want you to try that with the second one on your paper there. I just don't think they give it to me big. Like, yeah, I want it bigger than this. That's the problem. Guys, the struggle is, I do this every year, but then I forget to save stuff, and then I end up deleting it. Don't delete your stuff. Save it, so you can use it again. You're like, whatever. Uh-oh. Eli, can I make zeros? Yeah, we can. Zero. And 0. Questions on us making zeros and taking them. We got rid of them. Carmen, what else can I do? Like how, where? Yeah, I can take away an x from both sides. And then, John, what else can I do? Or am I out of things I can do? We could take a 1, like a positive 1 off each side. What else can I do, Antonella? Or am I out of things I can do? Yeah, we're out of stuff we can do, so let's write down what we have. What do we have over here? 2x. And guys, that really means 2 times x. So let's go ahead and write down 2 times x equal to, what do we still have on the right side? 4. Now here's the trick. This math is not always easy. I'm not sorry to use the bad word, but I think what times 2 makes 4. I think a lot of us got that. This is not always easy. So what we have to do is the inverse operation. Who knows? Somebody just said what I need to do. What do I do on both sides? Yeah, divide by 2. Please show this. Please show this on your paper. Please have it for when you do your homework and you can look back at it. To turn 2x into just 1x, we divide by 2. And that's how we get what x is. Try the third mat on your own. If you get that done, go ahead and try your homework problem. Try that third mat on your own. See if we can get to what 1x is. What did you figure out x is? Interessante. So they tell us that we're equal. Marina, what can I do? And you don't necessarily have to go in order, but it helps. What's the first thing we normally look for? Yeah, we can make zeros, right? So cancel out. I like what you said, because making 0 is canceling out. So this is 0, goodbye. This is 0, goodbye. What else? Kylie?
You can get rid of the 2 in the corner at the top.
Ooh, there's a 0 here. Goodbye. Ooh, positive, negative. They're not right next to each other, but do I have a 0 here? So these also, I'm just going to kind of circle across. Those also say goodbye. Eve, do I have more zeros? Positive, negatives? Check that right side. I think we got some shaded, some empty. Like if I circle this, is that a 0? Yeah, so there we go. We got that. Wait, I got a... Wait. What do I have left on the left side? X. What do I have left on the right side? So wait. Could X be 0? Yeah, it's how many pizzas I'm ordering right now. It's how many jumping jacks I'm doing right now. It's how many miles I'm running right now. X is allowed to be 0. This confuses a lot of kids. Like, X has to be a number. 0's a number? 0 is also a person over probably in the pod, but 0's a number. That is allowed. Vincent?
It's also a number that breaks all math equations.
Well, it doesn't break all math equations. Actually, it's like, in certain things, it is really important, where it's like the identity. So it's the addition identity, but with division, it totally breaks the machine, right? Like if we try to divide by 0, the machine's like, I can't do it. So yeah, you're right. Certain things it breaks, other things it's really important. So X equals 0, totally allowed. Guys, I want to do this again for that second mat. So for that second mat, whether you put it on graph paper or whatever, I want to do that again. Just real quick before you guys get out of here, on a clear ink. So, but here's how I want to do it. I want to do it without the mat. When we started, we had 3x, actually I'm going to write a little bigger. 3x plus 2 plus negative 1 equal to 1x plus 1, 2, 3, 4, 5, 6 plus negative 1. And now I'm going to throw the mat away. So here's what we had to start. Can I do... Now my board's getting possessed. Can I do 2 plus a negative 1? Yeah. It's really like subtraction, right? What's 2 minus 1 or 2 with a negative 1? We get 3x plus 1 equal to... Can I do 6 plus negative 1? Yeah, so I get 1x plus 5. Hey, if you're packing up, I sure hope you already know how to do this. Because I told Goldring every now and then I'm going to steal a couple minutes because I have to do that lunch count. Now, we do stuff on both sides. So, I think the way you guys walked me through it was take away an x on both sides. Remember, that's 1x. So over here, we still have 2x plus 1 equal to 5, because my x is gone now. And then we take away the 1, and we get back to where we were. 2x equals 4. And then you should already have this on your paper. We then divided by 2. This is what we're going to practice tomorrow, that we don't need an algebra mat. We can do it all on our paper. Please try your homework. Otherwise, you don't benefit. I beg you. I will bribe you. I just got to figure out how. Actually, homework contest is back on, so.
That's a bribe.
Homework contest is back on. I just don't have last week's data yet.
Sort of a bribe. That's a bribe. It's like a pass.